Okay, we're going to do Wilcoxon again, and again we've seen this data before. This is the performance on S3 tests before and after a one-day revision course. So we're doing the signed rank. So step one is to state our hypotheses as normal. Okay, and these are going to be the same hypotheses as we had for a signed test. So the null hypothesis is that the median change in score is 0, and the alternative hypothesis is that the median change is, well, the claim is that the students' test scores increase. So if I'm doing the change, then that should be a positive median change for the organizer's claim to be true. I've used the word median. Now, because Wilcoxon always assumes a symmetrical distribution, you may see the word mean being used, but you're always safe saying median. So there are my hypotheses. Now I've got to work out the differences, and I've got to rank the differences. So the first difference, 50 to 68, is a difference of plus 18, and the next difference is a difference of minus 1. So I'm going to go through, I'm going to do the second value minus the first value to get the change. So when the scores go up, I want the changes to be positive. So there they are. Now what we commented on last time we looked at this data is that the increases like 37 and 35 and 30 and even 15 tend to be bigger in size than the scores that went down. So we may see a change in our conclusion because the Wilcoxon signed rank will take this to some extent into account. What I need to do next is rank these differences. So I've got two differences of 1, so ranks 1 and 2 both get assigned here, so that's got to be a tied rank of 1.5 using up ranks 1 and 2, and they're both negatives. And then my next smallest one, I've got another tie here. I've got ranks 3 and 4 are both 2s. One's positive and one's negative though. So this is a tied rank of 3.5 for 3 and 4. And that's a minus and that's a plus. And then that's used up ranks 3 and 4. So rank 5 is this minus 3. And then I've got a minus 4, which is rank 6, and a minus 5, which is rank 7. And I've got nothing else in single figures, so rank 8 is going to be this 11, and then 9 is going to be 13, and 10 is going to be the 15. Oh, I've missed out another 13. There was a ranks 9 and 10, so a shared rank of 9.5 is going to be for the two 13s. And then rank 11 is going to be for the 15. And then I've got a rank 12 of the 18. And then we've got 13, 14 and 15 for these last three. So, I've forgotten to put on the pluses and minuses. That was positive. These were all positive. That was minus. That was a positive change. That was a positive change. These are minuses. That was positive. That was positive. So the sign test took into account the numbers of positives and negatives, and it wasn't very impressed by the comparison. But what we might now see is that the actual ranks for the negatives, let's work those out first. So the negative ranks, what do they add up to? So the negative ranks will be, well, 1.5, if I just do it from right to left, from left to right, plus 5, plus 7, plus 6, plus 3.5, plus the other 1.5. Okay, what do they add up to? That's 6.5, 13.5, 19.5, 23, 24.5. Okay, and to be on the safe side, I should also check the total of the positive ranks, and I should check, as we did before, that these add up to what they're supposed to. So I've done that, and I've got a total for my positive ranks as a 95.5. And when I look at the page that I'm going to need to check out anyway for my critical value, then it gives me that reminder of how to check. So the upper tail should be half n plus 1 minus the lower tail. And that will apply to my two values as well. So I need to do a half n times n plus 1 times 1 minus 1 of my values. So this is just the check. A half times, what's n? I've got how many students on the course? I've got 15 students on the course. So a half times 15 times 16 equals 120. So it should be that if I do 120 minus 24.5, I should get this number. And you do, you can check that. So my check has worked. That's not part of our solution, but it's a nice thing to do just to make sure you've done your calculations correctly. So the one of these I choose, well, remember the table works with the lower tail, so I choose the smaller value. And that's got to undercut the value, the critical value I find. To help with the critical value, I need a value of n, or we've just done that, n is 15, and we need a significance level, which is 5%, and I need to remember whether this is two-tailed or one-tailed. Well, looking at my hypotheses, I didn't say it, but I should have done, because I'm only interested in a median greater than 0, this is a one-tailed test. Okay, so this is one-tailed. So that's the information I need to go to the table with. So going back to the table, 5% significance, one-tailed, n is 15. So n is 15, here it is. One-tailed 5%, we're in the second column for 15. And the value we get here is 30. So that's the value I need to undercut. So my critical value, there are marks for your critical value. My critical value is 30. So my comparison is between 24.5 and 30. All right, and 24.5 is less than 30. Now we're in the lower tail. Okay, so that means 24.5 is in the lower tail because it actually undercuts the 30. So this is the significant at the 5% level. Okay. It says very clearly in the booklet, and you need to remember that if you actually get equality here, if your value equals the critical value, that also counts as significant. Okay, but here we've actually undercut it, so it's definitely significant. So because it's significant, we're going to be rejecting H0, and so our conclusion in context is going to be, we can't believe that the median change is 0. We do have evidence that the median change is positive. So there is evidence at the 5% level to conclude the median change is positive. So what that means is we are going to accept the organizer's claim. Okay? All right, now what assumption did we make for this to be valid? Well, we're using the Wilcoxon signed rank test, and that's always the same assumption, that we have to assume that the population of differences in the scores is symmetrical. That's the key word, symmetrical, but you need to say the whole thing. All right, and now we're going to compare the result of that with what we did when we did a sign test. Well, here was the comparison I ended up doing here. With the sign test, we had a very unimpressive probability here that woefully failed to be significant in comparison with the significance level of 0.05. And the reason, and so we had a completely different outcome. So for this one, we accepted H0. We didn't find any evidence the median score had improved. And the reason for this big difference is, as we commented, the sign test completely fails to notice that the negatives correspond to really small differences like -1 and -3 and -4 and -5, whereas the positive differences in some cases were really quite huge changes in marks. So as long as the assumption is valid about the symmetry, the Wilcoxon signed rank test does tend to give you more chance of detecting an effect if there is a real effect. So we can write, we have a different conclusion. The Wilcoxon test has taken the sizes of the changes into account, and its ability to do that means that we say it is a more powerful test when it can be used than the sign test.